Okay, this next question, with this next question, it's a word problem. And the word problem is a shoe store has a cost of 5x plus $25 and a revenue of negative x squared plus 5x plus $3, where x represents the number of pairs of shoes sold per week. Find the company's profit equation if profit equals to revenue minus cost. Now, the thing about word problems, when you are trying to solve a word problem, you can't just read it once and expect to know everything, how to solve it. What you got to do with the trick with the word problems, you got to read it once to get the gist of it, and then you read it twice to get, what do they want? What do they want you to solve? And after you know what they want you to solve, you read it a third time to find out, okay, we know what we want to solve. What are we given? What things are we given? So we read it once already. We get the gist of what the author's the question is. They want us to. The question is: a shoe store has this cost of dollars and some revenue of dollars, right? The X represents number of pairs of shoes sold per week. Find the company's profit equation if the profit equation equals the revenue minus cost. Okay, what do they want? They want us to find the company's profit equation. Okay, and we're given, and we read it again. Look at it again. A shoe store has, what are we given? A shoe store has a cost of 5x plus $25. So we're given cost, right? It's our cost. And we're also given revenue. They have a revenue of negative x squared plus 5x plus $3, right? And we're also given x. They tell us that x represents the number of pairs of shoes that are sold per week, right? So let's put down what we're given. We're given cost. Cost equals to 5x plus 25. Revenue will equals to x minus dollars. Negative x squared plus revenue equals to negative x squared plus 20 plus 5x plus $3. Okay. And they specifically tell us that x represents numbers of pairs of shoes per week, sold per week. Okay, and that's what we have. And look at the equation they gave us. Profit equals to revenue minus cost. That's the equation that's given, right? Profit equals to revenue minus cost. Revenue minus cost. Okay, since they gave us that, let's plug in revenue into the word revenue. Revenue is equal to x, negative x squared plus 5x plus 3. And let's plug in cost. And remember, there's a negative sign there. Let's plug in cost. Remember, whenever we're plugging something into another term, we open up the parentheses around it and dump in the given term that they gave us. So let's put in cost now, which is 5x plus $25. And it equals the profit. Hey, guess what? This looks much more easier than what we had before, doesn't it? So let's look at the left side of the this profit equation, and we see that x squared yada 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 is inside the parentheses. Okay, that's simple. We can ignore that because there's nothing inside that parentheses that we can simplify. Then we look at the right side. we look inside it and you don't see anything that we can simplify any further, right? But look, there's a negative in front of that parentheses. So guess what? We have to distribute this negative indivisible 1 into all the terms inside the parentheses. So negative 1 times, or negative times 5x is going to be negative 5x. And a negative times positive 25 is going to be negative 25. Great. Now, since we look at this side, we can just take out that term outside the parentheses because it's meaningless there now, and put down all the terms. Now we're going to look for the same species again. Let's bring down negative x squared. Do we see any other x squared species? Nope. So x squared is by itself. Now we look for at the next term, which is 5x. Do we see any other x species? 5x, negative 5x. Yep, so let's bring them down. Positive 5x minus 5x. Now let's look at the next term, which is 3. It's a constant. Do we see any other constants? We have 3 and we have negative 25. Great, let's bring them down. Positive 3 and negative 25. Okay, let's add those like terms together. We have negative x squared. Positive 5x minus 5x is 0, so it's gone. Okay, now look at the next couple. 3 minus 25, right? So we're going to take 3 from negative 25 is going to be negative 22. Okay, good. Let's simplify it further. We get negative x squared minus 22. So our profit equation, our profit would equal to negative x squared minus 22. And an x would be, if, let's say we have 5 pairs of shoes sold that week, right? We put that into our x, and out will come how much profit we made that month. Okay, let's continue on with your homework. X cubed times x squared. When you multiply like things of like bases, the exponents are added together. So it will be x, it will be equals to x to the power of 3 plus 7. Okay, great. And the answer will be x to the 10th power. Next one. We have like bases, great, y's. So the exponents will be added together when the like bases are multiplied. So it will be y to the power of 9 plus 2. Answer is y to 11 power. Next, a to the invisible 1 power times a squared. They're like bases. So we're going to, the answer will be a to the power of 1 plus 2 equals to a cubed. And 2b, invisible 1 power, times 2b to the 4th power. We have, they're of the same species, b's, right? So we will multiply 2 times 2. It would be equal to 4. And b times b to the 1 power of 1 plus 4. Okay, and that will be equal to 2 times 2 is 4. B to the 1 plus 4. 1 plus 4 is 5. 5th power. Good. Next one. P squared times Q to the 7th power. P to the 7th power times Q to the 4th power. Okay. We will multiply like terms, like bases. P squared plus P squared times P to the 7th power. Put them together and put Q to the 7th power times Q to the 4th power. Wonderful. And that will be equal to P to the 2 plus 7 power times Q to the 7 plus 4 power. And that will be equal to P to the 2 plus 7 power is 9 power. And Q to the 7 plus 4 power is 11. Next one. 3a to the 7th power, all cubed. What we're going to do here is use the power rule to put into the 3 and the a to the 7th power. So you're going to put 3 into both of those there. So 3 cubed, it'll be 3 cubed times a 7 times 3. Okay, put 7, when we use the power rule here, 3 will go into the 7, right? 3 times 7, so it'll be 3 cubed times a 7 times 3. Great. Now let's simplify this. 3 cubed is 27, and a 7 times 3 is 21. Good. Okay, next one. This is 7. Okay, 3r cubed times s to the 6th power, all cubed. So we're going to do it again. Use the power rule to distribute into all the variables and numbers. So we're going to have 3 cubed times r cubed, right? Cubed again, times s to the 6th power cubed. Let's simplify. 3 cubed is 27. And that's going to be multiplied by r cubed. Again, we can use the power rule here. 3 times 3 is 9, right? We'll put that later though. S6 to the, you're going to use the power rule here. 6 times 3, right? And we're going to simplify it further. 27 r 9th power s 6 times 3 is 18th power. There's your answer. Okay, next one. This time you have a parentheses within the parentheses, right? So it's going to be negative m power 4 all cubed times a negative m to the power of 8. And remember, anytime we have an even exponent, it will always be positive when the variable inside is negative. If it's odd, it would stay negative. If that negative was outside the parentheses, then it would, and it doesn't matter if it's even or odd, an even or odd power, it would always be negative. For example, you see this here? If you have m to the 4th power, or m to the 8th power, or m to the squared, or m to any power, right? Any even power, the answer will be still negative m to the 4th power, right? It looks just like that. Okay, now the difference between this and the other one is that this time the negative here is inside the parentheses, and if it's inside the parentheses, it's going to come out positive. It's if the power is even. In this case, the power is even. If it's odd, it will be negative. If it's even, so it's going to be positive. So for that one, negative m power of 4 will be positive m to the 4th power, all cubed, times negative m to the power of 8. Oh, okay, negative m to the power of 8. Good. Okay, so this one will also be positive. Negative m is inside the parentheses. The power is in even power, so it will be positive. Good. Okay, so now we're going to use the power rule. 4 times 3 is 12, m to the 12th power times m to the 8th power. And these like bases are the same. When we multiply two like bases, we add the exponents. So it's going to be 12 plus 8. 12 plus 8 is the 20th power. So m to the 20th power should be your answer. Okay, next one. Z to the power of 8 all to the 4th power. Okay, we're going to use the power rule here. Distribute the 4 into the exponent, and we should have z to the power of 8 times 4, and the answer should be z 4 times a. power. Good. Okay, next one. Y to the power of 4n times y to the power of 3n. We're going to use the exponent rule. We have two like bases, two the same species. We're going to add the exponents. Y to the power of 4n plus 3n. And look, the n's are the same. We can add the top species together. Y 4n plus 3n will be 7n's, right? So y to the 7n power. Let's do some other problems. Okay, next problem is p power of 3 plus n times p power of 2 plus 9. I mean 2 plus n. 2 times n. Okay, so since the bases are the same, right, we're going to add the exponents. That's the exponent rule. So it's going to be p times p to the power of 3 plus n plus 2n. Okay, add like terms together. 2n plus n is going to be 3n plus 3. That's the answer. Okay, next problem is that thing over there. Okay, so since we look inside the parentheses, right, we see that the bases are the same in the numerator. So we're going to add, when we multiply bases, and their exponents will be added together. So a to the 4th power times a to the 5th power will be a to the power of 4 plus 5. Okay, and if we look at the denominator, it's going to be a plus 1, I mean a to the power of 1 plus 3, right? All of that is squared to the power of 7. Good. Let's simplify a to the power of 4 plus 5. That will become a to the power of 9. And the denominator will be a to the power of 4. Great. And now let's use the power rule. Put the 7 into the 9 by multiplication. Okay, so it'll be well, we can also do 9 minus 4, but I don't want to do that. We're going to use the power rule first. So a to the power of 9 times 7. Okay, and then divided by a to the power of 4 times 7. You got to multiply the power of 7 into the numerator and into the denominator. We could have done it the other way, but this is just for you to see a different way, the way of things. So the power of the answer should be a to the 9 times 7 is 63. So the power is a to the 63rd power, and the bottom is a to the 28th power, because 4 times 7 is 28. Good. We can subtract 63 from 28, and we're going to get 35. So the answer should be a to the power of 35. Great. Now, next one. We look inside the terms here, and we see that it's already simplified. I mean, it's already good. So what we're going to do here is distribute the 3 into all of the constants and the variables. So negative 3 to the 3 to the negative 3, and then 3 to the power p over p to the 2nd power, and then 3, and we're going to put that, you can use the power rule here, 9, 3 into the 4, okay, by multiplication. Let's show it. Okay, so in the numerator, we're going to have parentheses, negative 3 to the 3rd power, and it times p to the 3rd power times power of 2, right? Opposite, other way. With 2 to the 3rd power, okay? And then times q power of 4 times 3, okay? Numerator, we're going to do the same thing here with we're going to use the power rule here. So 5 is going to be put into all the things inside. So we're going to have negative 1 to the power of 5. Good. Good. And then times p to the 4th power times power of 5 times q to the 2nd power to the power of 5. Okay, let's go back to the numerator, and I'm going to simplify this further. Okay, and we should have Negative 3 to the power of 3 would be negative. Anything negative with the power of an odd number would always be negative. Right? If it was squared, it would negative 3 times negative 3 would be positive. But because it's odd, negative 3 times negative 3 is positive, times negative 3 is going to be negative again. Right? So anything to the odd power and there's a negative inside the parentheses and it's power of odd, it's going to come out negative. Like so answer will be negative 27. Okay, p to the second power times the third power is going to be it will be 6. You'll see later. We'll add that later. Okay, so 2 times 3 is 6. Right, add that 6. And then times q, 4 times 3. 4 times 3 is 12. So q to the 12th power. Right, let's do the denominator. Negative is inside the parentheses. Negative 1 to the power of 5. Look, it's odd, so it's going to be odd. Negative 1 times p to the 4th power times 5. So 4 times 5 is 20. Q to the second power, 2 times 5. Distribute that, use the power rule. 2 times 5 is 10. Okay, so next step is to try to simplify it further. Let's see what we have here. We have, let's look at the constants here. Negative 27 divided by a negative 1. Negative divided by negative is positive. So we're going to have positive 27 in the numerator. Okay, if we look at p to the 6th power, we look at the like bases, p and p, we have 20 minus 6. When we divide, we subtract the exponents. And we're going to go to the one with the greatest power, the 20. So 20 minus 6 is going to be 14. So p over 14 will be in the bottom. And we look at a q over 12 divided by q over 10. They're like bases. So when we subtract it, we're going to go with the one with the greatest power. So 12 minus 10 is going to be, erase that, q over 2. Q to the second power. So 27 q to the second power divided by p to the 14th power. Okay. Next one. 3 times parentheses x plus 2 to the 4th power divided by parentheses x plus 2 all squared. So with this one, we have to first of all, there are like factors here. We see that x plus 2 here is the same as the numerator's factor, which is also x plus 2. They're the same. So guess what? We can cancel them out. We can treat these two factors as bases. We can treat them as like what we did before with the q and the p. So let's treat this thing inside the parentheses as one whole thing, one whole organism. And look, they are the same organism. They are an x plus 2 organism. And there's 4 of them, right? Here on the bottom, we have the same organism, and there's 2 of them, right? So guess what? We're going to take the power of 4 and the power of 2 and subtract them, just like we did with the other ones before. So we're going to have 3, right, times x plus 2, organism, 4 minus 2. Right? When we divide like bases, their exponents are subtracted. Now, the answer should be 3 x plus 2 to the power of 2, because 4 minus 2 is 2. That should be your answer. And we're going to leave it that way. Right? That's all I want you to see. You can go further, but we just leave it that way. Right? Now the next one is if you did simplify this further, remember you cannot distribute the 3 into x plus 2. You cannot do that. You know why? Because look here, you have a square connected to this thing. Don't distribute. Don't make that mistake. If you want to distribute the 3 into the x plus 2 first, you have to remember your PIMDAS. You have to first start with the parentheses and your exponent. So you would break open this. We can break open this first, right? It will be x squared plus 4x squared plus 4, right? And then you can distribute 3 into it. Okay. So 3 times x squared would be 3x squared. 3 times 4x will be 12x. And 3 times 4 is 12. Got it? All right. Next one is x minus 1 all cubed times x minus 1 to the 7th power. And in the bottom there, we have a parentheses within the parentheses, x minus 1 all squared, and then that is to the 4th power. So the first thing we're going to do, we see that we have, again, 3 organisms that look the same. Though on the top, we have an x minus 1 organism, right? And it looks the same with its counterpart, x minus 1 organism. And we have the one at the bottom, the same. So basically, we can treat these all like the same base, like one big organism, right? So when we multiply like bases, their exponents will be added together. So let's treat these organisms as like bases. So x minus 1 to the power of 3 plus 7 would be in the numerator. And when it goes to the bottom, here we can use the power rule. X minus 1 is an organism. So x minus 1 squared, use the power rule. So it will be 2 times 4. Great. Let's simplify this even further. Look at the numerator. X minus 1 organism. 7 plus 3 is 10. Great. Now, x minus 1 organism. 4 times 2 is 8. And look, we have one big organism on the top and on the bottom. They're both the same, aren't they? All right, so let's treat them like bases. So 10 minus 8 is going to be 2. We're going to go with the one with the greatest power. So the numerator disappears. So it will be x minus 1 organism, power of 10 minus 8. 10 minus 8 is 2. Let's get rid of this, erase all the stuff, and we're going to do some more problems.